Hello everyone, how are you all? I hope all good. So in this video we are going to solve a lead code problem that is cuckoo eating bananas. So the problem statement is here. The cuckoo loves to eat banana. There are n piles of banana. The ith pile has piles I bananas. The god have gone and will come back in 8 hours, right? So in this problem statement we are understanding that one person cuckoo is here and he she likes to eat banana, and in n piles there are n piles and ith pile has a pile I banana, and there is a guard. The guard comes back, means he is visiting there, and he comes back in 8 hours, right? So cuckoo can decide her banana per or speed of k, means she can eat per hour k bananas. Each hour she choose some piles of bananas and eats k banana from that pile. If the pile has less than k bananas, she eats all of them instead and will not eat any more banana during this hour, right? Are you getting this point? Now the cuckoo likes to eat slowly but still want to finish eating all bananas before the guard return, right? Before the guard returns, she want to eat all the bananas. So return the minimum integer k. What is k? K is per hour speed of eating bananas, right? Such that she can eat all the bananas within 8 hours. Now this is the problem example. This is pile and this is hours and this output. So how this output is to be generated? Now we take an example by this. Let's suppose we have pile P, right? So in this pile we have some ith piles bananas, right? So each pile has some piles of bananas, that is 3, 6, 7, 11, 3, 6, 7, and 11. This is zeroth pile, first, second pile, and third pile, right? So if we imagine that we have given that the k per hour pile speed is k, so we imagine c can eat one banana in 1 hour. So if one banana c can eat, so we can imagine in this pile c need to eat 3 hour. 3 hours will take to eat finish this, and now for this 6 hours, for this 7 hours she will take, and this is 11 hours. So if we add this, then this will be greater to age. Our age is initially 8, right? And this answer is greater than this. This is 27, right? So 27 is greater than age. The total hours is 8, and for this she is taking this much hours. So what we can do, we'll simply increase this. We will simply increase k by 2, means she can eat k bananas, means 2 bananas per hour. So if we increase, then if she can eat k bananas, now in this she can take 2 hour, in this she can take 3 hour to finish, in this she can take 4 hour, because 2 3 is a 6 and 1 is left, so 4 hour will she will take, and in this 6 hour, right? So the total is even 15, and 15 is greater than, right? 15 is greater than 8, so we cannot take this. Now again increase this by 3. So if we take 3 bananas, so in this example C can finish, right? In this example, if C eat k bananas, means 3 bananas per hour, means 1 hour will take, 2 hour will take, and 3 hour and 4 hours will be taken by her. So in this 4 3 7 and 3 10. So in this example also 10 hour will be taken by her. So this is not fulfilling the constraint. So we will increase this by 4. Now 4, this will take 1 hour and this will take 2 hour. Obviously this will also take 2 hours, right? Because 4 2s are 8 and this is 7. So it will take 2 hours, and in this C will take 3 hours. 3 hours she will take. Now the total is 3 to 5 and 3, 8. So in this 8 equal to 8, and we need the optimal answer, that is 4. Now this answer is 4. But in this problem, we are taking number wise linearly. So the answer may be quite bigger and it can take too much time to execute that. So for that, what we can do, we can simply use binary search. And you know very well binary search. What is binary search? We'll take initial position as start 1 and e as a end. And we will take int max, right? I am int max we will take. So we will check first middle of this, right? If the middle element is denoted as a k, we will take mid element and that denote k. If the r is greater, then we will move. If r is greater, it means this. R is greater, then we need to decrease that r. So for decreasing that r, we will simply increase the value of mid, because in this mid, suppose this 3 is mid, so 3 for 3 we are taking the answer is this. So if the answer is this, then we are increasing the value, right? If the answer is greater, then we will increase the mid element, right? We will increase the mid element. But if the answer is less, this is equal. But if the answer is less, let's suppose 6 for this, then we need a optimal solution. This 6 hour will take to complete this, and now we have remaining 2 hour also left. So what we can do, we can also optimize that solution. For optimizing, we will decrease the value, right? This mid element we will decrease, right? So now we come to the statement and do the problems. So first we take input as a start int initially 1 int and as a 1 e9. This is the limit of int max, right? Now we can run a while loop start to end. Okay, and we need a for loop for that. Files dot size I plus plus, right? We will here check the divide count, means we can divide how much we can use. So for that we need a int value, that is mid start plus end minus start divided by 2, right? Okay, then we will check the piles I divide by mid, means that mid element, how many bananas can eat in that particular hour. So mid, as we have seen, the mid denoted k, right? Mid is denoted k, means this hour, in this hour she can eat this much bananas. So this has been done now, and there can be some remainder, there can be some remainder, right? So if there is remainder file I module mid, so if there are any remainder, it means we need to add 1, right? So the answer is divide plus 1, right? But if there is no remainder, means the answer we need to add only divide. Here I think you are getting my point why we are doing this. So let's understand this. So in this, let's suppose we have this array. So initially we check this as a mid, right? This is our mid. So we will first check, this is our mid element, means k, here k is 1, or k is 1, Okay, and we will check here all the element. That first element, this the k is 1 means 3 hour will take, 6 hour will take, 7 hour will take, and this 11 hour will take for this is k. In k hour, how much element can be eaten by this? So 1 hour. Okay, so like this we are checking every element. So for doing that, for every pile we are counting. Here we can count, then again for 6 we will count, for 7 we will count, for 11 we will count. So for every pile we will count element. That's why we are just adding the number in answer. So we will take the answer in long. Answer initially is 0, right? And this answer, the answer is 0 initially. Again and again we are going to 0 it, right? This has been done. Now what we can do, this is loop completed. Now the while loop is not completed now. So we will check if the answer is greater than ours. It means we have taken, or c took greater than h hours. So what we will do, we will simply, if as we have seen in this, if the answer is greater, if our answer is greater, then we will increase the value. We will simply increase the value mid plus 1. But if the answer is less, then we will, if the answer is less, then we will simply decrease that mid minus 1, right? This is our problem is done now. So in this problem, what we also can do, we will simply add one more initial base condition. That is, if the piles dot size equal to 1, it means there are only one pile, right? And we will take the we will simply add that, like divide equal to piles of I by hours. In this example, only if the pile size is 1, it means there are only one hours, means there are only hours condition and pile size. So we will simply divide by that and check remainder piles I remainder of h. So remainder remainder is there, okay, if remainder is present, it means we will return the answer divide plus 1. But if not present, we will return divide. So I guess this problem has been done now. We'll check first answer this pile mid element and this mid and remainder. Take this aid at the element if answer is greater. If our answer is greater, means the k value is greater, then we will simply increase that, because we need to increase the value of k so that our hours of completion can be decreased. Right now, after completion of this full, we will return the element. Now run and check the answer. Okay, there is pile I. The we have to take 0 here, also 0. Now run it. Okay, this has been done. All the test cases are correct. Now we can submit it. So let's submit and check the answer over here. Okay, this is correct, submitted. So I hope you find this video helpful. And if you like this video, then please like, share, and subscribe, and share with your friends so that they also can learn this programming logic as well. Thank you very much for watching these videos.